So hi, hello, and welcome to Versatile DataKit community meeting. I'm going to quickly share the agenda for today. We have on the agenda really fast, quick round of intros, introductions of who are we and who is here, and then we're going to present the latest release by Antoni. And also, maybe you can give also a quick introduction to what is VDK. We had actually a couple of weeks ago a Versatile DataKit team meeting, and I'm going to share what are the outcomes of it. And then we're having practical Kimball data patterns by Antoni. So yeah, let's get started. And I think first we can kind of introduce us ourselves. Who are we? Whoever wants, we can go. Actually, I will start because I'm kind of hosting this meeting. My name is Agita. I'm community manager of Versatile DataKit project, and yeah, basically that's it for my quick intro. Whoever wants to go.
I can go. My name is Gabriel. I've been with the VDK team for almost 2.5 years at this point. The last project I worked on were the VDK DAGs, and now I switched to the Jupyter integration. And yeah. Anyone else?
I'll go next. My name is Paul. I've been on the team for about 6 months. I'm a VDK software engineer. Recently, I was working on improving the CI/CD, and now I'm going to start working on looking at use cases for how we can gather LLM data using VDK.
Hello, my name is Duygu, and I have been in the VDK team for a year now, and I'm mainly working on the Jupyter integration.
Okay, I can go next. I'm also part of the VDK team, maybe for a year now, and I'm one of the contributors to the project. And I'm Stanislav. Nice to meet you.
Thank you.
Okay, I'll go next. Hi, my name is Dylan. I've been on the VDK team for about 6 months now, and my most recent contribution is working on the open sourcing of the VDK operations UI, which Antoni will talk about some more. Yeah, currently addressing some tech debt that's left over from that. After that, we'll see.
I can go next. My name is Daku, and I've been more or less a contributor and also a user of the VDK project. I'm part of the team which uses the VDK, which has a VDK deployment inside of VMware, and we have more than 150 teams using it now internally. And that's it.
I can go next. Oh, sorry.
Go.
Okay, so I've been part of the team for a couple of months now. Been working on the VDK DAG and now switched to the VDK Jupyter plugin.
Yeah, I just want to say that these meetings are completely publicly open, so you don't have to be in the VDK team to be here. So if you just if you are here to listen to us, to see something to present, if you wish to say a couple of words, introduce yourself, go ahead.
Hi, I'm Frank, VDK user and fan. That's it.
Thank you. Okay, if not, then I think we can move on with our agenda. So Antoni, I'm passing the word to you.
You're on mute. Okay.
Hi. Yeah. So Versatile DataKit entry point is the GitHub repo, Versatile DataKit, from where you can create a quick inset. What is the VDK? What challenges it solves? And there's some preview of some of the capabilities. We are hoping to actually to make this in the future to represent better all the capabilities in the multi-brief one, but you can see how versatility it allows data engineers to create data jobs that can ingest or process data. They can develop it, run them, debug them locally, and finally they can deploy them, manage, operate them in the runtime environment that can provide by Versatile Data Kit. And the part that's actually missing is how people can also operate those kind of data jobs. This is actually what was most recently added in the latest release, the VDK Operations UI, which allow users to view the overall health of all data jobs, to enable, disable data jobs, to list them, to execute the details, things like which is the version of the data job being used, how it's scheduled, source code, and so on. With the including of the operations UI, we sort of consider the open source version of Versatile Data Kit as covering every part of the development cycle, DevOps cycle, from development to deploying to monitoring operations. That's why we decided to mark it as a release of 1.0. You can find out more information in the different demos in the YouTube channel of Versatile Data Kits, and you can see how to get started with local installation of a VDK Operations UI using VDK, QuickStart VDK, or you can also get an overview of some of the capabilities. Or if you are more engineering inclined, you can also check the architecture in the enhancement proposal. So this is probably the biggest release and feature included in the 1.0 version. Other important features that are being developed, and the first one is the Control Service Secrets API, which is provided by DACO. The Secrets API users can now will be able to store sensitive data such as password, credentials, tokens, and so on. For that to be possible, the people who are installing the Versatile Data Kit backend, the control service, would need to simply configure a vault instance in the control service, and end users would have data engineer, data analytics would have directed and easy access through VDK SDK to store secrets and fetch secrets. This part includes just the REST API changes. I know that DACO is working on introducing also VDK SDK changes that will make it easy to set and get secrets in data job. And finally, important introduction is introducing quality checks in some of the templates of VDK in Power. Previously, Stefan Bodor, who is not here on the call, introduced first check template in the insert template, in the vault template, I mean. This proves to work well for that team, and they're now adding support for data quality check in a few other templates, and eventually they'll add it for all. With the introduction of template checks, people can now basically write a very simple check by specifying this function. Doesn't matter the name of the function, but they can create a function which should accept table name, temporary table name, and they can run quality check against this table. This table would represent the data as it is before being loaded in the final table, target table. This allows you to make sure that the data being transformed meets your criteria for quality. before actually being written in the final destination. The- yeah, there are much more changes, of course, in this release, and you can check all the detail notes in what's changed in the release notes. In the here in the open source. Yeah, I think that's it. Any questions, comments, concerns? Okay, cool. I think that was for me. Okay, what was the next on the agenda?
The workshop.
Cool.
So, yeah. So a couple of weeks ago, as I said, our team met for a workshop. This is the picture that we took during the workshop. So I'm gonna just briefly explain what we did and actually the outcomes of what we learned, what we did, and actually what are the outcomes. So we had several, let's say, workshops or lectures or something like this, like sessions on how people are using VDK. Then we had some design principles sessions, such as Don't Make Me Think design and data-centered design. And we also had product management for driving meaningful customer impact session, where we kind of learned and we got some knowledge to use it later for some brainstorming sessions. And basically the brainstorming sessions were on these 4 topics: on the VDK contribution process, on kind of vision, direction, and goals. So we tried to align on what we think is VDK and where it should go. And ease of use, because this is one of the main, let's say, directions at the moment for VDK. We want to make it easy. And then we had a retrospective. So the first brainstorming session was on the contribution process. It went something like this, like what we should keep doing, stop doing, start doing, and then we had some action items. And I think main outcomes is to actually review and compare with other projects and what they're doing, like check for the best practices, do a knowledge transfer with other maybe internal projects that we know. Also, we have VDK t-shirts, and we have sent them to some of our previous contributors. And I think we should keep doing this, but we don't have like a proper process for it. So if you wish to contribute, or we are going to also possibly receive a t-shirt from us, and we are going to have like a nice process for this. Then continue discussion on local testing and debugging process. So these are kind of the main highlights of this meeting. By the way, you can just interrupt me anytime if you have something to add. Maybe I'm just missing some information. So then we had one session on vision, direction, and goals. Basically, as I said, we aligned or kind of saw the big picture of what each of us is seeing, what is VDK and what it should be and where it should go. These are actually our real like sticky notes that we had there, but I'm gonna sum them up. So for the vision, we set kind of easy and clear, easy to use and clear to understand. Efficient, which is really kind of fast to get started and start using. Attractive meaning attractive for potential people. I also kind of correlate this with useful. And stable means that it's reliable and basically it works. So the direction is to create sort of a unified toolset. We want to basically provide unified way of the full data engineering life cycle. And actually what we've done before, I think, was kind of expanding on features, but now it just came up that, or it was really a highlight that we should more work on existing or improving existing features rather than working on the new ones. And of course, README and documentation should be also improved to become more clear and understandable, I think, for the users or people who are coming into our repository. Anyway, so then we went to the goals. Basically, the goals that we set are creating YouTube tutorials, and now we have quite a lot of tickets for creating some explanatory short clips or like longer clips on how to use VDK. Then one of the also main focus is no code or ease of use and efficiency, so fast to get started and possibly no code getting started. Then with the features, actually, we decided to have for each new feature that we decide to implement, we have a real user or use case, and we know that it's going to be used. And yeah, improvement of README documentation. So then we had another like special brainstorming session on how to make VDK easy to use. And what we use is this 6 thinking hats method. Basically, when we kind of decide what we do, then we state facts, brainstorm, list advantages, disadvantages, and then how we feel, and make a plan. I'm just going to share a couple of like, let's say, images from what was there. Like basically, one is that we are not at the moment measuring how easy it is to use VDK, and then we decided maybe we should also evaluate this ourselves by ourselves, and also with the users of existing users of VDK and also external users of VDK. And then yeah, a couple of things of how we feel about this. And here I also want to highlight that Gabi hates the fact that there is no create button in UI. And then we made a plan, and basically kind of out of the discussion, I think what was a really highlight for me was this Jupyter notebook idea that we are developing Jupyter notebook integration, but maybe we're not so much speaking about it or like validating it with external users, which I just started doing like this week. And basically also analyze the users that are using and how they find VDK. Let's say gather some feedback and yeah, do some surveys and see how the people who are using VDK are evaluating us in the sense of ease of use, and then how we can improve it. Then we had a retrospective. I just want to also quickly mention a couple of things. How to find the contributors is something just to think about, like kind of action item. Finding a dedicated blogger, we found a person possibly to blog about like VDK, how to use it also, and actually a real like writer, a person who actually knows what they're doing. Yeah, and open source VDK workshop conclusions is actually this thing that I'm presenting now. And then there's a discovery phase for initiatives, but I actually don't remember what it was. Maybe Stanley, you can say a couple of words on this.
Yeah, basically the idea here is that our current approach more or less is we have an idea or initiative that we would like to work on, and we directly jump and start working. Maybe it's better actually to spend some time in a discovery phase first. So basically a couple of people to talk to users, to make some researches, etc. Basically to identify what is exactly the work that we would like to have, to scope it, and then to start officially working on that initiative. And we'll see whether the second approach will make our life a bit better, I would say.
Yeah, okay, clear. And CI/CD, I think it was someone else, maybe Paul or maybe Gabi.
I think it was Paul, no?
Yeah, we're going to set that up soon, but we need to get it more stable first.
Okay, so basically that's it from my side. I have nothing else to add on this topic. If there are any questions, I can maybe answer.
Hi, so Varun here. Am I audible?
Hi.
Okay, so I am basically a data engineer, and we are connected on LinkedIn. So I basically wanted to know, so like I build data pipelines on a user story basis, and I use AWS Glue, Lambda, and I connect to on-premise data sources. And today basically is my first day with VDK, so I'll be anyway going through the repo. So I just wanted to know, where does VDK fit in this scenario, and how can I utilize it?
Yeah, so VDK SDK, quick start VDK if you want to see it, is something that you can use to actually write your pipelines, where you can install it locally, you can develop inside it. It provides a certain very simple structure, and you can create SQL steps and Python steps and to execute them in order. You can test some, and then you can debug, test, and if you install, there are some plugins, like for example, install VDK plugin, you can see some lineage transformations, and so on. So the primary goal of the data framework is to help you make you develop efficiently, either locally or if you want, you can use.
And so it can
somewhere else.
integrate with like multiple cloud environments and like on-premise as well, right?
Yeah, it's Python, so you just need Python.
Okay.
It has different plugins, which you can install. For example, if you want to talk to Snowflake, you can install plugin for VDK Snowflake. If you want to talk to Postgres, you can install plugin for Postgres. If there is a missing plugin, then you can just contact us and we'll add it fairly quickly.
Okay.
Okay, this is the part that is probably most gonna be useful to you in a cloud environment. There is also other parts which allows you to deploy on parade jobs. This part though requires somebody to install it in a Kubernetes cluster. But if you're using a cloud version with AWS Go, generally AWS Go take care of this kind of things. So you probably won't end up using it.
Okay, understood. Thank you. Yep, I'll go through the repo and have more questions.
Oh yeah, feel free to ask them. You have a Slack channel, GitHub discussion.
I'm going to quickly show, actually we're connected with you, so you can ask directly me, but if you go to the repository here, when you scroll down, you will be able to see how to connect to us with us on Slack. So you join the workspace and then you join the channel Versal Data Kit. So there you can ask all the questions.
Okay. Yep, thank you.
Thank you. Okay, so Antoni, I think we can proceed with your part.
Sound good. Cool. So yeah, today I'm gonna talk about practical Kimball data patterns. It's primary knowledge sharing session, and actually there is gonna be at the end a little bit of VDK, but not much. I hope I find it insightful. Basically, I'm gonna go very quickly over the data engineering process. What is the dimension about modeling? I'm gonna drill down into what is actually Kimball. Kimball splits into 3 independently usable parts: architecture, process, and techniques. And finally, show how Versal Kit implements parts of some of those techniques. Yeah, quickly. So the data engineering, often the data engineering cycle goes through these stages, right? You first need to sort of have some kind of business questions that you need to answer, or business problem. And with that, facing this problem, you need to discover the data that you need and explore it. This is the first part. Then you need to get this data and get it integrated somewhere. This could be a data lake, or this could be simply locally on a Jupyter notebook. And after that, you tend to transform it. And this is really the development part. And ultimately, at some point, you need to schedule and deploy it and manage it. Do you agree with this? Do you see some missing step? Yeah. And similarly, very similar promise is the data science process, except we also do ML modeling. So before going to, let's go over what do we mean by data modeling. Ultimately, data modeling is the process of defining how data is structured, organized in order to be able to meet certain business requirements, right? So when we usually when we go talk about data modeling, when we create a data model, this kind of data model, we're gonna use data warehouse and databases. So this could be tables. This kind of data model is something that you can use to create reports. You can use it in a training algorithm to train some data. You can use it, other data engineering teams or other data engineers can use it as an input in their own data model, in their own data model creation. You can also use it to create more interesting products for your customers. And because data model has so many different users, ultimately in some way it's a product. Going to the data mesh concept of treating data as a product, that's why it's important to treat your data model as a product as well. Like this means that it needs to be tested as a software product. It needs to have monitoring. In the data model part, this is quality checks. It needs to be stable and scale well, and needs to have service level agreements. And very important, it needs to be easy to use. For its users, it needs to be understandable and clear and easy to use, the way you want software product to be easy to use. As a full context, often data models are used as input into training ML models. So yeah, we distinguish data modeling from ML modeling. The data model may undergo very simple transformations to be created into features, usually converting categorical values into numerical and things like that, and can be trained to model object. Dimensional modeling, what it helps is provide you, make it easier to treat this data model as a product. But before we explain why, let me introduce first what actually dimensional modeling is. Dimensional data modeling is a technique that was introduced by Kimball in the 80s, 90s, kind of forget, don't remember exactly, but some time ago, that recommends creating data model based on two types of tables primarily. One of those is a dimension table. The dimension table is what we call the descriptive part of the model. Often we can find, let's say that we want to model this kind of business process, which is person boarding airplane. So for example, when you're doing this kind of data modeling, you're thinking about your model, you can try to explain it in one single sentence. If you can do this, is like, that will be incredible. I would like to use this quote by Mark Twain, is that if I had more time, I would do it shorter. So I'll be able to get this kind of complete process on the model into one sentence. Would be pretty impressive, but also be extremely useful to be able to do it. So let's say that the business process on the model is Antoni is boarding a plane at 7 p.m. from Washington to New York using Ryanair. Well, so this is the business process that I want to model. In this case, the dimensions, the things that describe our business process answer the question of who, what, where, why, how. this is the dimension. The fact is generally goes around the verb. It tends to be the numerical values also, describe the numerical values and the action. So in my sentence, when I point out, the dimensions would be who, Antoni, when at 7 p.m., where, starting place, New York, to Washington, what airline, Ryanair. Well, the fact would be me boarding the plane. That's the action. And the dimensions. So this is also fairly easy way to track when I try to think about what is the starting dimension to be able to very quickly answer the question. If you manage to describe your business model in a sentence, things around the verb in the sentence tends to describe the fact, and the things, the descriptive parts tends to be the dimensions. So what are the benefits of dimensional modeling? If you go back to treating data as a product, we want our product to be easy and simple to use. So dimensional modeling provides kind of simplicity and improve understanding, because you can see how very simple it is to decide what fact in the dimension table is. So easy to understand and much more user friendly. It's considered more intuitive to business users. Generally, dimensional model tends to be less normalized. So that means that you can query data and try to answer questions with this model with less joins, for example. So that tends to be much better performant in analytical systems. Because dimensional models are designed in such a way that your dimension represents central entities, and you know exactly what's the dimension, the fact. It tends to be to make it easier to provide consistent view of the data across the business. And finally, because the dimensional models tend to be organized around business categories, it's easier to interpret them, understand them. So now that we are happy and convinced hopefully that dimensional modeling is really a good data model that we can utilize. It's not the only data model. There are things like in-mode data modeling and VAUT, which represent other alternatives, which in some cases can work better, but we're not gonna discuss them here. We're gonna go into details what actually dimensional modeling is, and particularly what is the Kimball dimension, which introduced by Kimball. So we're going to talk about the Kimball. Kimball introduces with three things: Kimball architecture, Kimball process, design process, and what I call design patterns or modeling techniques, a way to model your data in specific ways. They are all three things are actually independent, and they can be used together, can be used each separately, just 1, 2, 3, or combination of them, doesn't matter. It's up to the person, business needs, and business requirements. So I'm not gonna delve too much into the Kimball architecture. This is probably the most highest level of the three. While I would say that the design process and the model techniques can be used by individual contributors, by any data engineer, data analyst who is trying to do data modeling in their own day-to-day activities. The Kimball architectures tend to be the data architect task. So the Kimball architecture proposes that you create your ETL architecture, pipeline architecture, by creating two layers. The top for the back room and the front room. The back room like the kitchen and the front room the dining room. You can read more about it in the Kimball group website, which is linked above. But I can just actually metaphor that's very sort of easy for me to understand because I used to work in a restaurant when I was a college student. I worked in I worked both in a restaurant in the kitchen, and a few years later I worked also as a waiter in a restaurant, another restaurant. So I kind of have the view of both. I remember, for example, right, I was cleaning shrimps, I was making eggs over easy, and so on. And I was really doing when I was in the kitchen preparation of the data. It seems a bit chaotic, but everybody had their tasks, and it was important that ingredients were clean and with good quality to be able to create good dishes. Another thing I remember when I was making an eggs over easy. Eggs over easy means that you need to flip the egg to the pan without breaking it, which took some getting used to it. So for example, there were days that I was not very lucky. I tend to break them more often than not. If you break them, you need to redo it again, which well takes time, and if you're extremely busy, it's not very nice. So sometimes I try to cheat and to pass a broken egg by hiding it behind the cash browser or things like that. But very often, and did this only once or twice, but the waiter would catch me and yeah, ask me, yeah, this is not good. The client is not gonna like it. Please redo it. This kind of metaphor can be brought back again to the data world, where yeah, you have this kind of staging area where you create your ETL transformations, and it's important that you rely on data that's good, and you have the steps working well, the jobs. And it's important that the output that you do, the dishes or the data model that you do is of good quality, right? That you have quality checks. In this case, the waiter was the quality checks for me. For data for a meal. And in the dining room, this is where you want the layout, you want really things to look well. People have menus so they can choose what they need. The service is prompt and good support, and the quality, the presentations and the usage of the food is good. It's very similar for the data. The backroom generally is off limits, like things are chaotic. There are very specific things in order that are done, and you don't want people to have access to those, to the raw ingredients or to the raw materials, because they can pollute them. Also, they are not ready, so you don't want people to try to eat raw unready things. That's why the backroom is off limits for anybody of the clients, and they just use the front room. This is kind of what Kimball, at the heart of the Kimball architecture, and of course, it's layered with metadata. So this was a very quick overview. I really recommend reading the article that I've linked because it goes in the same metaphor with kitchen dining room and does it pretty much better than me. So let me go to the second thing. The second thing that Kimball introduced is the Kimball dimensional design process. These are 4 simple steps which help you create your data model. Kimball recommends creating data model incrementally. So you focus on different business processes and you start building your data warehouse, different dimension and fact tables incrementally one by one. If you go back to my example, we started with just one business process, which is the person boarding the plane. There could be another business process is the checking account of a person in the bank, checking his account at the end of the month. So you need to answer 4 questions or determine 4 things to be able to sort of build this kind of data model. In the Kimball design process, the first thing is you need to make sure that you define the correct business process, right? This generally is one of the hardest things. So you need to, if you manage to get to this one sentence where you describe your business process in simple one sentence, then everything else would fall down very easy. This requires a lot of thought, a lot of talking with stakeholders, a lot of talking with product people, and making sure that you really nail it down. Right, I've done some very simple examples, like people boarding a plane or somebody checking a car balance. Generally, business process tends to reflect the real users, what they're doing. After that, you need to identify the grain. The grain means refers to the level of detail that you want to track. It comes generally from the business process, a lot of it. So we're talking about example boarding a plane. You can see that the grain is the actual event happening. A person boarding a plane. This is probably called transactional grain. It's the smallest grain. Checking account balance. This could be a high grain week, days, month, because let's say that we don't need to. We can check. We can have only monthly account balance if that's what the business needs. Again, depends on the business requirements. But in our example, I'm going to use a month. So let's say that we need to check the bank account balance each month, and the specific grain would be the boarding pass counting the gate of the passenger. You can see how it's very user-oriented and speaking specific events. The second one. After you identify the grain, the third thing that's recommended in the Kimball dimensional design process is to identify the dimensions. As explained, if we manage to get our business process to one sentence, this should be fairly easy step. We just look at the descriptive data in the sentence, which answer the question what, who, where, how much, how long, and so on. So in the example I'm using for account balance, that will be when the date for the month, the customer whose account balance is looking at the bank, where is it, or for boarding a plane, the day the passenger arrived there, and so on. And finally, the fourth step that's recommended is identifying the facts. And if you have again your one sentence, you're working around the verb and the action. So in our case, the checking account balance is the fact would be the account around the account balance snapshot, because we just check it every month. Or the passenger boarding event would be the fact for the boarding a plane. And that's what represents the Kimball dimensional design process. And with that, you have your own data, first data warehouse and data model. Before we go on to the specific modeling techniques, any questions so far? And the third thing that Kimball introduced is I'm calling the Kimball dimensional modeling techniques. You can also call them design patterns because they are patterns for designing your different tables. Generally, what we mean by modeling techniques, if you need to create some kind of dimension or fact table, there are different general patterns that you can use depending on what data you need in the fact table or the dimension table. and transforming all the data you can use those patterns to upload the data in a fairly similar way. So those are some of the fact and dimensional patterns or modeling techniques that are introduced by Kimball. And I'll go very quickly, perhaps, hopefully not around them. The first one is called transaction fact tables. This is if our grain is again every event or every transaction. In some ways, this is the simplest one, but also the one that contains the most granular information. Of course, tends to have the biggest tables. Arguably, I think this might be also the most commonly used. Basically, each event is stored in the fact table only once. You just append to the fact table when the event happens, and you keep track when it happens. Generally, you will those for this kind of day-to-day operations that happen, and you want track users what they are doing. With boarding complaint being one example. The second type of modeling technique is if you want to track a summary at a regular interval of something. So, for example, we want to track every month the account balance of every customer. The grain is generally at some aggregated level, for example, the month, and you store the state of the facts as they exist in the moment you track it. Or you can include some averages at that moment. It has a snapshot called the date, for example, the month, and the balance, for example, in the example I'm using, the balance for each customer in the month. So in this case, periodic snapshot table, the example is month per customer. So you can say that the primary key of the table will be the customer for each month in the month. The third type of table is accumulated snapshot fact table. If you want to track a process that goes over multiple steps, for example, this is showing an order pipeline. So when you have an order, first somebody calls the order, then perhaps go into a backlog. For some more complicated order, you have manufacturing. Somebody needs to create it. For example, we ordered a new bed. Somebody needs to manufacture it and create the new bed and finally ship it to us. And of course, we need to pay. This is something that goes through multiple steps and takes time. If you want to be able to quickly answer your organization questions as what are the current what are all the current orders that are being shipped, or what are all the current orders that are manufacturing, or how long it takes to get between stage X and stage Y. These kind of questions are very easily answered with the accumulating snapshot fact table, because you track the processing pipeline in it. You do it by basically having each row represent the single thing you want to track, in this case, the order. And you have column for each of the steps. Usually, you can see the blue box. You have the dates for when different step was completed, or you can also have the date that started and finished if you want to track it at that level. So order date, backlog date, shipment date, and so on. And you can have some order quantity, shipment quantity, different. And this kind of accumulated snapshot table is updated over time, where these rows get updated. Like initially, the shipment, the order date will be no, right? Nothing. You have just order date, and it'll start getting populated over time. So that's the third type of accumulated snapshot fact table. And yeah, that's basically my introduction to Kimball design patterns. VDK provide some kind of capabilities to be able to implement some of those modeling techniques, and I'll show them in a bit. Any questions so far about what I talked about?
I think it was pretty clear.
Usually, if there are no questions, it means that nobody understood anything. So, no. Sure, that's true. But thank you. Cool. So, yeah, that is a reminder of what Versatile Data Kit is. It provides you ability to create ingestion jobs, automation jobs, store jobs. Ultimately, the Kimball data patterns fall into the transform data jobs. By the way, there's a prepared exercise which goes through this process. We're gonna update it. Currently, I think it's a bit too complex. But if you wanna try it yourself at home, feel free. It does take about an hour and a half, I'll be honest. We're gonna update it to take like 20-30 minutes or even less. I mean, soon, I hope. But still, it's an option. But before, so let me share my GitHub page and show you how Versatile Data Kit provides support for some of this kind of modeling techniques. So if you go to the wiki, here we have examples. And the data processing data using Kimball Data Warehouse. Currently, so Versatile Data Kit provides this kind of concept called templates. Templates are basically reusable data jobs. You can hide a lot of complexity, basically another data job behind it, and you can just execute it with a single method. Versatile Data Kit has developed implementation of some of the modeling techniques that I showed. I focus on the modeling techniques for creating fact tables, but Versatile Data Kit also provides support for some modeling techniques for creating dimension tables, like small change dimension type 1, small change dimension type 2. You basically, to be able to use it, you just you'll create a data job. Data job is a SQL inside the Python or SQL steps, and in the Python steps, you would create or would invoke execute template function, and you provide the template you want to use. For example, this example is using small change dimension type 1, std1, it write the arguments. The arguments tends to be the source, like the delta, the new data that you want to ingest or rather transform, and the target dimension of the dimension that you want to update or create. There's support for small change dimension type 2, which allows you to track basically source code version, because it allows you to track the changes over time of the data in a more compressed and easy to query way. And there's also support for transaction fact table. You just called also append strategy, where you can append your data, or periodic snapshot table. Append strategy can be used also to create a periodic snapshot table, because it basically makes sure that each period is represented once. Insert strategy would allow to create a transaction of fact table. This is yeah. This is something that anyone can check the examples. You can try it here on your own at home. And yeah, this was basically what I wanted to share. We are close to the end, so I wanna thank you for listening to me. I hope you find it useful. And feel free to ask me now questions if you outside of VMware. You can always contact me either through GitHub discussions and just ask questions here. To the Slack channel. If you're really shy, you can just search me on LinkedIn, Antoni Ivanov, and find me there as well. Thanks.
By the way, Antoni, it was a great presentation. Maybe Agi, after the meeting, you can share also the presentation that Antoni was going over.
If it's uploaded somewhere, I can link it to YouTube, maybe, and also we can share it on Slack.
Yeah, okay.
Yeah, it's uploaded. I'll send it.
Good. I think it was really good. Yeah. Thank you, Antoni. I just want to give like a second for some questions. Maybe someone has any.
Nobody? Did nobody understand anything?
I guess. Anyway, so just to then maybe conclude this meeting. I propose that the next meeting is on 26th of July. I just want to check if maybe there's something happening in Bulgaria.
I believe until the next year, nothing will happen. So.
Okay, great. Okay, so there's a link to Google Calendar and also in our repository. If you go to Wiki, and then there's community meeting and open discussion notes. So basically, this is the link to the time and date of the next meeting. I can also share it quickly in the chat. No, I cannot. Let's see if this works. And yeah, I wanted to also to share that we have a YouTube channel where we are publishing all of these meetings, and actually there are a couple of playlists where we explain how Versatile Data Kit works to get started, and yeah, all of the community meetings are in this playlist. There's some introduction, something about ELT, and also there are a couple of videos about the operations UI that we just released. So yeah, I think it's a really good source of information. Yep, and actually that's all from my side. If there's nothing else to add, then thank you everyone for joining, and I hope to see you next time.
Thank you. Bye-bye.
Bye.
Bye,
Thank you,
guys.
everyone.
Hey guys, bye.
Bye.